Hi, I am Satyanarayanan. Welcome to our channel. Let's impart knowledge and education. You can reach us through senddoubts@gmail.com. To see more videos, subscribe our channel and don't forget to press the notification button.
Hi friends, today I am going to teach you steady state steady flow energy equation derivation. Initially I am considering a control volume system. It has one inlet pipe and one outlet pipe. Initially I am assuming a constant mass flow rate fluid is entering into the system as well as leaving the system. At inlet condition, I am considering four important parameters, that is pressure, specific volume, velocity and datum head. Similarly, at output section, I am considering the same pressure, specific volume, velocity and datum head. At inlet section, the naming is suffixed with 1. At outlet section, it is suffixed with 2. So, P1, V1, C1, Z1 is inlet section. P2, V2, C2, Z2 is outlet section. Now, we are going to see about the units. For mass flow rate, the unit should always be taken as kilogram per second. For pressure, the unit should always be with kilonewton per meter square. For specific volume, the unit is meter cube per kilogram. You know that for volume, the unit is meter cube and the naming is capital V. If it is a specific volume, it should be denoted with a small v, that is lowercase v. Specific means the term is divided by kilogram. So whenever the term is divided with either mass or mass flow rate, it should be called as specific. The velocity of the fluid unit is meter per second. The datum head, also called as elevation or also called as height, the unit is meter. Now listen carefully. The mass flow rate, the symbol is small m with dot over it. For pressure, you have to use only small p. For specific volume, you should always use small v. For velocity and elevation, you can use uppercase character, that is capital C and capital Z. This elevation is nothing but the height between ground level and axis height at inlet section. Similarly, for outlet section, the elevation is the height between ground level and axis of the tube. Mainly, for any thermodynamic system, when the fluid is flowing through any system, you have to consider four important energies. Here I am going to discuss about four important energies. First energy is internal energy. It can be called as U. Flow energy, also called as flow work. It should be denoted with the PV. Kinetic energy is nothing but C square by 2. Potential energy is nothing but Gz. According to first law of thermodynamics, we know very well, sum of energy flow rates at inlet is equal to sum of energy flow rate at outlet. In the previous slide, I have discussed about the four energies involved. That is nothing but E1 at inlet, energies at inlet. E2, energies at outlet. In addition to that, for all the thermodynamic process, you have to consider two more parameters. That is Q. Q is nothing but heat supplied. Heat supplied at inlet section. Whenever the heat is supplied to the system will deliver work output. So that is denoted as W suffix S. That is shaft work. Now, this equation is expanded like this. Listen carefully. This term is nothing but four energies discussed in the previous slide. This Q is kept as it is. Look at this. This Q is kept as it is. This term is nothing but E1. For your understanding, I am following the same color code. For output section, this Ws is kept as it is and E2 is mentioned here. You can observe that this is internal energy, this is flow energy, this is kinetic energy and this is potential energy. All the energies are involved with the constant mass flow rate. So I am taking mass flow rate as a common for both inlet and outlet section, where Q is nothing but heat supplied to the system and the shaft work is nothing but Ws. We know very well the enthalpy is denoted as H. The enthalpy is nothing but sum of internal energy and flow energy. So H can be written as U plus PV. In the previous slide, I have shown you the basic steady flow energy equation. We have discussed about this. Now I am going to explain you in detail. Listen. This U1 plus P1 V1 is nothing but enthalpy at inlet section. So this term can be replaced with H. Similarly, at output section, U2 plus P2 V2 is nothing but enthalpy at output section. This can also be replaced with H. Listen carefully. So this equation becomes like this. This Q is taken as it is. M is here. Instead of U1 plus P1, I am using H1. All other terms are remain same. Similarly, Ws, M, instead of U2 plus V2, I am using H2. All other terms remains same. Now, another important step, I am bringing heat and work done to the left hand side, all energies to the right hand side, so that the unit can be easily balanced. Look at this. Q, this Ws becomes minus Ws when it is brought to the left hand side. Similarly, all the energies you have to consider sign convention carefully. This Q and Ws unit is kilojoule per second. Kilojoule per second is nothing but watt, because 1 joule per second is nothing but watt. So this can also be called as kilowatt. For mass flow rate, you know very well, the unit of mass flow rate is kilogram per second. For enthalpy, the unit is kilojoule per kilogram. If it is a velocity, the unit is meter per second. Here velocity square is there. So you have to use meter square per second square. The unit of potential energy is joule per kilogram. You can observe that for the first three terms, the unit is kilojoule, kilogram and kilojoule. For the last two terms, you can observe instead of kilometer, it is meter. Instead of kilojoule, it is joule. So I am going to convert this in kilo form. So you have to divide these two terms with 1000. Listen, instead of 2000 is there. Here 1000 is there. So the unit becomes kilometer square per second square. Here kilojoule per kilogram. Now the unit can be fully balanced. In the next slide, I am going to teach you how to balance this equation. Listen carefully. This unit conversion is very important in steady flow energy equation topic, because while solving the problem, the question may be twisted with the unit. So you have to be very careful. Listen, the first term is mass flow rate into enthalpy. Second term is mass flow rate into C square. Third term is mass flow rate into Z. That is mentioned here. Now mass flow rate into enthalpy. Mass flow rate is nothing but kilogram per second. This enthalpy is nothing but kilojoule per kilogram. So this kilogram gets cancelled. Remaining kilojoule per second is written here. So this is called as kilowatt. I have already told you 1 joule per second is nothing but watt. So the equation unit is kilowatt. Now here mass flow rate is kilogram per second. This C square is nothing but kilometer square per second square. This is very important. I am going to expand this unit in a suitable form. That is kilogram as it is. Instead of kilometer square, I am mentioning it as kilometer into meter. Kilometer into meter. This remaining second is mentioned here. Now listen. This kilogram, kilometer, second square, this entire term is nothing but kilonewton. Keep it in mind. Remaining thing is meter per second. This meter per second is mentioned here. 1 Newton meter is nothing but 1 joule. So this equation, this expression can be mentioned as kilojoule per second. That is also called as kilowatt. So first term also kilowatt, second term also kilowatt. Third term, mgz into 1000. This is another very important step. Listen carefully. Mass flow rate is nothing but kilogram per second. This gravitational force G is nothing but 9.81. This Z is nothing but kilometer. Now listen carefully. Whenever a mass, that is kilogram, multiplied with 9.81, this becomes Newton. Listen carefully. kilogram into 9.81 is Newton. Remaining kilometer is there. So kilometer. At denominator you have second. So this Newton meter is nothing but joule that I have discussed here. So this kilonewton meter per second can be written as kilowatt. So the entire equation will be in kilowatt. Now I am going to rewrite this equation in another form. Both will be helpful while solving problems. Listen carefully. I am going to divide this entire equation with the mass flow rate. Listen carefully. I have already told you, whenever a term is divided by mass, you have to use specific. Here it is called as Q. Here the term is divided with the mass, so it is specific heat. Here heat, it is specific heat. Here it is called as work. Here it is called as specific work. So look at the letters. Here I used uppercase character. Here I used lowercase character. This expression is divided by mass flow rate, so m gets cancelled. Remaining term will be keep as it is. Okay. So this is the another form of steady flow energy equation. Regarding unit conversion, you have to be very, very careful. This is nothing but kilojoule per second. This is nothing but kilojoule per second. Now it is divided with the mass flow rate, that is kilogram per second. This kilojoule per second is divided by kilogram per second. I am leaving this unit conversion to you. Once it is divided by kilogram per second, this equation becomes kilojoule per kilogram. So listen carefully. This is very, very important. These two things are very important while solving the problems. I have mentioned again here. Small q is nothing but capital Q divided by mass flow rate. Small w is nothing but capital W divided by mass flow rate. So the application of steady flow energy equation will be discussed in the next video. Thank you for watching.